All right. We're going to get into hierarchy and scale, but first, want to do a quick review of linear, that is arithmetic, and geometric growth. This is going to be important because scale has a lot to do with, we get into geometric stuff in our thoughts about scale. So let's invent a bit of a data set here. So we're going to have a set of data that have time, and then we're going to have, and this time is going to be 1, 2, 3, 4. And then we're going to have a linear process, and we're going to have an exponential process. And then the linear is going to go 10, 20, 30, 40. So the linear is the times 10. And then over here, we'll start with the same amount, 10. But then at 2, it's 100. And at 3, it's 1,000. And at 4, it's 10,000, which is 10 to the 1, 10 to the 2, 10 to the 3, and 10 to the 4. So we can see here that in this column, the process goes as, instead of 10 times t, it's 10 raised to the t power. If we then plot those with t and n, we're going to call it here, where this goes 1, 2, 3, 4, and 10, 20, 30, 40, 50, 100. Well, then the linear ones go like 10, 20, 30, 40, right? And the exponential ones go 10, 100 off the scale. All right, so we get that. That's how we get this, thing. Now, we can fix that. Fix it. Another way of seeing this is to make another plot where we have time along this. Then we have 1, 2, 3, 4. Then we can have 10, 100, 1,000, and 10 to the 4th. And when we do this, we again get our straight line. So this is a linear plot, sometimes called lin, because linear, same increment here, plus 1, plus 1, plus 1, plus 1, and same increment here, plus 10, plus 10, plus 10, plus 10. This one is called, sometimes it's called log, lin, sometimes it's called semi-log. And so log is logarithm. So, and logarithm is this number here. 1, 2, whoops, that's not true though. I'm going to relabel my y-axis here. 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4. So it's logarithmic on this scale and linear on that scale. Now this is important because when we start trying to think about things over lots of space or lots of time, and then the numbers can get really big, but also many things in nature have a property more like this than like this. So in some of the things we're going to do in the next few videos, we'll be using graphs like this one. And when you look at graphs on, I'm going to put a bunch of pictures for you to look at. One of the exercises coming up is going to be to look at a bunch of pictures. Pay attention to what's going on this axis. There's another kind that's called log-log, and there are many processes in nature that have that distribution, but we'll get to that. Well, actually, you'll see some of those. So always pay attention to what the increments on the axes are. And to start, we're going to be looking at things like this because diseases have that, exponential growth processes are easy to look at like this. Things like the size of earthquakes. We're going to talk about earthquakes quickly in a little bit as well. All right, so that's it for a quick review of linear and exponential functions. More to come.